1997 BC 20, we're asked for all values of x for which this series converges. So we're looking for the interval of convergence. Now, a couple of shortcuts that you can use in some of these cases. I can tell that this is going to be the center. The center is going to be x equals 2. Now, knowing that, and knowing that when I have an interval of convergence, which in each of these cases the answers all have intervals of convergence, it has to be symmetric about the center. So I know that it's not going to be either A or B. So that basically tells me that the interior of the interval of convergence is going to be x is greater than -1 but less than 5. Now all I have to do is test the endpoints really quickly there. When I plug in x equals -1, I'm going to get -3 to the n over n times 3 to the n. Now -3 to the n, if we wanted to, we could split off that -1 that does the alternating of the signs, and that would leave me -1 quantity to the n, 3 to the n, over n, 3 to the n. And seeing that my 3 to the n's will cancel, that leaves me with the alternating harmonic series. Converges. Alternating harmonic. So I know even further now that C cannot be the answer since -1 converges. Now the only question is, does this converge when x is equal to 5? Well, when I plug in 5, I'm going to get just 3 to the n over n times 3 to the n. And once again, 3 to the n's cancel, and I'm left with the divergent harmonic series. And that tells me then that my final answer cannot be D either, but has to be E. So in a short time, I've been able to find the correct answer choice. Now, doing this work out, I'll show that the interior of the interval of convergence actually has to be -1 to 5, and we would show that normally using the ratio test. Limit as n approaches infinity of absolute value x minus 2. We want the n plus first term over n plus 1 times 3 to the n plus 1, and we'll multiply that by the reciprocal of the nth term, n times 3 to the n, and that's over x minus 2 to the nth power. Now, simplifying, we get n over n plus 1. We know that that limit is 1. Then we have 3 to the n over 3 to the n plus 1. And we know that that limit has to be 1/3. And finally, we have absolute value x minus 2 to the n plus 1 over x minus 2 to the nth, and that is going to give us just absolute value of x minus 2. So finally we're left with, there are no more n's, so I don't need the limit. I have x minus 2 absolute value over 3, and this has to be less than 1. I multiply through by 3, I get x minus 2 absolute value has to be less than 3. So x minus 2 has got to be less than 3 but greater than -3. Adding 2 to both sides gives me x greater than -1 but less than 5. So this is the long way about finding the interior of the interval of convergence, but we could have looked at the original problem and seen the x minus 2 quantity to the nth power and just assumed or guessed, conjectured that the center was at 2 and that the interval has to be symmetric about that. So in this case would have to be -1 to 5. Hopefully that helps.